Imagine a time before time, a place before space, a realm where the very concepts of time and space did not exist. It's almost impossible to fathom, but this was the state of the universe before its inception. This was the singularity, an infinitely dense point containing all the matter and energy of the universe. Picture a point so small yet so dense that it held within it the potential for everything we know today. Then, about 13.8 billion years ago, something remarkable happened: the Big Bang. This colossal explosion was not just an explosion of matter, but an explosion of space itself. This event marked the beginning of our universe. In an instant, the universe began to expand from a subatomic size to something that could be measured in light years. From that point onward, space itself began to expand rapidly, like a balloon inflating at an incredible rate. This expansion was not uniform, it varied in different regions, leading to the formation of various cosmic structures. As the universe expanded, it cooled, allowing matter to form from the primordial energy soup. The cooling process was crucial, as it allowed particles to slow down and combine to form atoms, the building blocks of matter. This marked the birth of stars, galaxies, and eventually planets like our own. Over billions of years, these stars and galaxies evolved, leading to the complex and diverse universe we observe today. From the tiniest particles to the largest galaxies, everything we see around us originated from that singular moment of creation. The Big Bang Theory describes the birth of our universe, a monumental event that set everything into motion. From a singular point, an explosion of unimaginable energy and matter created the cosmos as we know it. But what about its end? Scientists have long pondered the ultimate fate of the universe. Will it continue to expand forever, or is there a more dramatic conclusion in store? One theory proposes a dramatic finale, the Big Crunch. This theory suggests that the universe, after reaching a certain point of expansion, will begin to contract. Just as the Big Bang marked a period of rapid expansion, the Big Crunch envisions a future where the universe's expansion slows, stops, and then reverses. This would be a cataclysmic event, reshaping everything we know. The Big Crunch theory posits that the universe's expansion, driven by dark energy, will eventually be overcome by the force of gravity. As the expansion decelerates, galaxies will start to draw closer together. This reversal is driven by gravity, the fundamental force that pulls matter together. Over billions of years, this gravitational pull could cause the universe to collapse in on itself. Imagine the universe as a ball thrown upwards. Initially, it ascends with great speed, propelled by the energy of the Big Bang. At first, the ball climbs higher and higher, much like the galaxies spreading out in the universe. The momentum from the initial explosion carries it far, but eventually gravity slows it down until it momentarily stops before falling back down. In the same way, the universe's expansion could halt and reverse, leading to a cosmic collapse. If the Big Crunch occurs, galaxies would collide, stars would merge, and the universe would become a hot, dense state once more. This could potentially lead to another Big Bang, starting the cycle anew. The idea of the universe ending in a Big Crunch is both fascinating and terrifying. It reminds us of the dynamic and ever-changing nature of the cosmos. While we may never witness this grand finale, understanding these theories helps us appreciate the complexity and beauty of the universe we inhabit. To understand the Big Crunch, we need to grasp the concept of the expanding universe. Edwin Hubble, a pioneering astronomer, made a groundbreaking discovery in the 1920s. He observed that distant galaxies were moving away from us. Furthermore, the farther a galaxy was, the faster it seemed to be receding. This observation led to the understanding that the universe is not static but is constantly expanding. Here's where the Big Crunch comes in. The Big Crunch is a theoretical scenario for the ultimate fate of the universe. It suggests that the expansion of the universe, which has been ongoing since the Big Bang, could eventually reverse. Instead of galaxies moving away from each other, they would start to move closer together. Gravity, the force that holds us to the Earth and binds galaxies together, exerts a pull on all matter in the universe. This force is incredibly powerful, and it acts over vast distances. Every object with mass attracts every other object with mass, and this attraction is what keeps planets in orbit around stars and stars in orbit around the centers of galaxies. If gravity is strong enough, it could eventually overcome the universe's expansion and cause it to contract. This would mean that the distances between galaxies would start to shrink, and the universe would begin to collapse in on itself. This process would be slow at first, but it would accelerate over time as the gravitational pull becomes stronger and stronger. Imagine a game of cosmic tug-of-war. On one side we have the force of expansion driven by dark energy, which is causing the universe to grow larger and larger. On the other side we have the force of gravity, which is trying to pull everything back together. These two forces are in constant competition, and the outcome of this cosmic battle will determine the fate of the universe. On one side, we have the outward push of expansion. This expansion is driven by dark energy, a mysterious force that makes up about 68% of the universe. Dark energy is causing the universe to expand at an accelerating rate, pushing galaxies further and further apart. On the other side, we have the inward pull of gravity. Gravity is the force that pulls objects with mass towards each other. It is the reason why we stay grounded on Earth and why planets orbit stars. In the context of the universe, gravity is trying to pull galaxies back together, counteracting the force of expansion. The fate of the universe, whether it expands forever or collapses in a big crunch, depends on which force ultimately wins out. If dark energy continues to dominate, the universe will keep expanding indefinitely. However, if gravity gains the upper hand, the universe could eventually stop expanding and start contracting, leading to a big crunch. This cosmic struggle between expansion and contraction is one of the most fascinating and fundamental questions in cosmology. If the Big Crunch does occur, it would be like rewinding the universe's history in reverse. As gravity gains the upper hand, the expansion of the universe would slow down, and galaxies would begin to draw closer together. Temperatures would rise as the universe becomes denser and denser. Eventually, stars would collide, and black holes would merge, creating a cosmic maelstrom of unimaginable energy. Ultimately, all matter and energy would collapse into a single point, mirroring the singularity from which the universe originated. Section 6. Cosmic Clues, Evidence for and Against the Crunch. So how likely is the Big Crunch? The answer lies in understanding the universe's density. If the universe contains enough matter, the combined gravitational pull could halt the expansion and initiate the contraction. However, measurements of the universe's density have yielded conflicting results. Some observations suggest the universe is close to the critical density needed for a big crunch, while others point to a less dense universe destined for eternal expansion. Section 7. The Case for Dark Energy, a wrench in the cosmic gears. Adding further complexity to the equation is the discovery of dark energy. This mysterious force seems to counteract gravity, driving the universe's expansion at an accelerating rate. The existence of dark energy, if confirmed and understood, would make the Big Crunch scenario less likely. It suggests that instead of slowing down, the universe's expansion is actually speeding up. Section 8. The Future of the Cosmos. What lies ahead? The fate of the universe remains one of the most profound questions in science. While the Big Crunch provides a compelling narrative for the universe's end, it is just one of several possibilities. Other theories include the Big Freeze, where the universe expands forever, becoming colder and more diffuse, and the Big Rip, where dark energy eventually becomes so powerful that it tears apart all matter. Section 9. Our place in the grand scheme, a universe of wonder. Regardless of how the universe ends, contemplating its ultimate fate fills us with awe and wonder. It reminds us of the vastness of the cosmos and the incredible journey that brought us here. As we continue to explore the universe and unravel its mysteries, we gain a deeper appreciation for our place within its grand scheme.